Why do some people get more done in 3 hours than most people get done in a full day? In 2009, a researcher named Sophie Leroy at the University of Washington published a paper to answer the question, why is it so hard to do my work? What she documented was something she called attention residue, the phenomenon where part of your cognitive capacity stays attached to a previous task even after you've moved on to a new one. You think you've switched, but the brain hasn't. It's still running the previous task in the background, consuming resources that were supposed to be available for the thing in front of you. The effect is strongest when the previous task was left unfinished or unresolved under time pressure, which describes with some accuracy most of what a normal workday looks like. By the time most people sit down to do their most important work, the cognitive capacity they need for it has already been spent on something else, and they have no idea it happened. Leroy's original experiment was deceptively simple. She split participants into two groups and gave both a task to work on. Before they could finish, she interrupted them and moved them to a second, unrelated task. The only difference between the groups was what she told them about the first task. One group was told they'd have plenty of time to return to it later. The other was told they'd be rushed when they came back. The group that expected time pressure showed significantly worse performance on the second task. What Leroy had found was that the brain doesn't cleanly close one task before opening another. It keeps an active representation of unfinished work running in parallel, a background process that competes for the same prefrontal resources needed to focus on whatever is in front of you, and the more unresolved the previous task feels, the stronger that competition becomes. This connects to something psychologist Bluma Zygarnik documented decades earlier. In the 1920s, working in Berlin, she noticed that waiters had an almost uncanny ability to remember complex orders in detail, but forgot them almost immediately once the bill was paid. Her subsequent experiments confirmed it. The brain maintains an open cognitive loop for unfinished work, allocating mental resources to monitor for an opportunity to return and complete it. Leroy's attention residue is, in part, the same mechanism applied to a modern workday. An unfinished task, an email opened but not answered. Each one opens a loop the brain keeps running, and a brain running multiple open loops simultaneously has less capacity available for the thing it's supposed to be doing right now. Leroy's data suggested that a significant portion of the problem is self-generated, accumulated gradually across the day, invisible until the moment you sit down to do something that requires your full attention and realize it isn't there. Think about how a typical workday starts. By the time you sit down to do the work that actually matters, you've already checked your email, opened tabs you won't close, and started something you didn't finish. And the cognitive capacity you needed for the important work has been quietly draining since the moment you woke up. Joshua Rubinstein, David Meyer, and Jeffrey Evans at the University of Michigan published research in 2001 documenting the cost of task switching at the neural level. Every time the brain shifts from one task to another, the prefrontal cortex, the region responsible for sustained attention and complex thinking, has to disengage from the rules and goals of the previous task and reconfigure for the new one. That reconfiguration isn't instantaneous, and it leaves a residue that makes the next switch more costly than the last. What that means in practice is that the person who checks their phone 3 times before starting their most important task of the day hasn't just lost those 3 minutes. They've arrived at the task with a prefrontal cortex that's already been depleted, before the real work even began. And it compounds. Leroy's research showed that the residue from unfinished tasks doesn't just disappear when you move on. The brain keeps monitoring those open loops, periodically redirecting attention back toward unresolved work in a way that's largely involuntary. Every unresolved item, an email, a conversation without a clear outcome, a task abandoned midway, is a background process running on cognitive hardware that was supposed to be available for the thing in front of you. The people who consistently get more done in less time aren't necessarily working harder or starting earlier. In many cases, they're simply arriving at their most important work with more of their cognitive capacity intact, because they've learned deliberately or accidentally to reduce what they're carrying before they begin. In a follow-up study conducted with Teresa Glom at the University of Minnesota, Leroy tested whether anything could be done about it. The intervention turned out to be surprisingly small. Before switching tasks, participants were asked to spend a few minutes writing down where they were on the current task. Not a full summary, just enough to externalize the open loop into something concrete outside their head. Participants who completed the brief writing exercise showed markedly less cognitive interference on the subsequent task than those who simply switched. The act of documenting the unfinished work appeared to signal to the brain that the loop was being managed, that it didn't need to keep monitoring it actively. This is consistent with what David Allen, drawing on cognitive psychology research, described in his work on task management, the idea that the brain is a poor storage system for open commitments. It's designed to flag unfinished business. Holding it indefinitely is what creates the drain. When an open loop gets captured in a reliable external system, the brain can release it. Otherwise, the monitoring continues regardless of whether you're consciously thinking about it. In practical terms, this means the transition between tasks matters more than most people realize. Taking 60 seconds to write down where you are before closing something, or to note the next concrete action on a project you're stepping away from, changes what you carry into the next thing. It's just closing a file the brain was going to keep open anyway. A workday that begins with a clear picture of what's unfinished, and what the next concrete action is on each open item starts with significantly less residue than one that begins by opening the inbox and seeing what's on fire. The brain arrives at the first real task having already processed its outstanding commitments, rather than stumbling across them as the day unfolds. Most people treat the start of a work session as the beginning of the work. The research suggests it's actually the most consequential part of the day, and the most consistently mismanaged. What happens in the 30 minutes before you sit down to do something important determines, in large part, how much cognitive capacity you'll have when you get there. Roy Baumeister at Florida State University spent years researching what he called ego depletion, the finding that self-regulatory capacity, the kind needed for focused work, operates like a limited resource that depletes with use. His early research, published in the late 1990s, showed that people who had already exerted cognitive control on one task performed worse on subsequent tasks requiring the same kind of effort. The more decisions and context switches the brain handles before the important work begins, the less capacity remains for it. This is why checking email first thing in the morning is so counterproductive. Each message introduces a new context and often a new unresolved loop. And that's what makes it expensive. A 30-minute session in the inbox before starting deep work is, from the brain's perspective, equivalent to running a cognitive obstacle course before a sprint. You arrive at the work already depleted. The alternative requires a shift in how the morning is sequenced, and it's simpler than most people expect. Starting the day's most demanding cognitive work before engaging with any reactive task, email, other people's requests, means arriving at that work with a prefrontal cortex that hasn't yet been loaded by anyone else's agenda. The first hour of genuine focus, protected from input, tends to produce a disproportionate share of what most people would consider their best work. Adam Gazzaley at the University of California, San Francisco has studied how the brain manages competing cognitive demands, and his research points to something worth internalizing. The prefrontal cortex doesn't just process information sequentially, it actively suppresses irrelevant information to maintain focus. And that suppression is metabolically costly. Starting the important work before that suppression load accumulates is simply working with the architecture rather than against it. Getting to the work with cognitive capacity intact is only part of it. What happens once you're there is equally consequential. Most people experience focus as something that either shows up or doesn't, a state that arrives unpredictably and disappears without warning. The neuroscience suggests something more useful. Focus is a state the brain enters gradually, and the conditions that support entering it are specific enough to be deliberately created. Judson Brewer, a neuroscientist at Brown University who has spent years studying the neural mechanics of attention, describes focused attention as a trained state, something that develops with practice rather than arriving as a fixed trait. His research on the default mode network, the brain system that activates during mind wandering, showed that people can learn to recognize when their attention has drifted and return to the task with less effort over time. The capacity for sustained focus isn't static. It responds to practice in a way that's measurable in the brain. But practice requires the right conditions. One of the most consistent findings in attention research is that the brain needs a stable, low-interruption environment to enter and maintain a focused state, because the prefrontal cortex has to actively suppress competing signals to sustain attention on one thing, and that suppression is harder to maintain when new signals keep arriving. This is where environment design becomes more than a productivity cliché. A phone visible on the desk, even face down, even silent, has been shown in research by Adrian Ward at the University of Texas to reduce available cognitive capacity simply by being present. The brain allocates suppression resources to it whether you're consciously thinking about it or not. Removing it from the room entirely, rather than silencing it, produces measurably better performance on tasks requiring sustained concentration. The same logic applies to anything else in the visual field that represents an unresolved task or potential input. Open documents, browser tabs, anything the eye can land on, and the brain has to decide to ignore. Each one is a mild but persistent draw on the suppression system. And clearing the workspace reduces the number of things the prefrontal cortex has to actively ignore while trying to focus on one. What most people discover, once these conditions are in place, is that the experience of focus changes. The first few minutes of a session still involve resistance. That's the brain transitioning out of a lower stimulation baseline, and it's normal. But past that initial friction, attention tends to become self-sustaining. The work starts generating its own pull rather than requiring constant effort to maintain. Sophie Leroy's original paper asked a question so basic it almost sounds rhetorical. Why is it so hard to do my work? The answer has very little to do with discipline or motivation. It has to do with what the brain is carrying when it arrives at the work, and whether the loops it's been tracking all day have anywhere to go. None of that is fixed, and all of it responds to deliberate design. The people getting more done in 3 hours aren't working harder. They've just stopped bleeding cognitive capacity in places they couldn't see, and arrived at the work with more of themselves intact.